Good morning, students. Today we are going for the chapter 13 Insolation. The sun continuously radiates heat and light energy in all directions. This is known as the solar radiation. The flow of energy from the sun to the earth and then into space is a complex process. This involves energy transmission, storage, and transport. Energy transmission is in the form of radiation, and whereas energy storage and transport occur in the form of heat in atmosphere and hydrosphere, lithosphere. Solar radiation is the only primary source of light and heat on the earth. Types of radiation. The sun radiation is made up of three parts: white light, VC, infrared radiation, and ultraviolet radiation. The sun also emits atomic particles called solar winds into space. Most of the particles of solar winds are charged electrons. These electrons affect the Earth's magnetic field. The energy needed for all movements and change on the Earth is provided by sun. Insolation. Amount of solar energy received by the Earth is known as the insolation. The sun's energy dissipated and scattered before reaches the earth. Only 1 part out of 2 billion part reach the earth. Out of total 100 solar energy, only 51% reach the earth. 35 is reflected back into space and only 14% is absorbed by the atmospheric layer including ozone during insolation. Terrestrial radiation. Solar radiation insolation strikes the surface of the earth. The surface of the earth radiates this heat back into the atmosphere in the form of long waves. The heat radiates by the energy in the form of long waves is called terrestrial radiation. There exists a state equilibrium on earth between incoming insolation from the sun and outgoing terrestrial radiation from the earth is known as heat balance. When both incoming radiation and outgoing radiation are balanced, it is also known as heat budget. Now, with the help of this diagram, I show you heat budget. Incoming solar radiation on the earth 51%. Now, only 14% is absorbed in the atmosphere and 13% is there. Now 35% is reflected back in atmosphere. 48% from the atmosphere, here it is outgoing radiation. Now 34% absorbed in atmosphere from the earth surface and 17% from the earth surface. It means 14 plus 34 equal to 48% in your atmosphere. How is the balance achieved? The balance of heat budget is important for life to survive on the earth since the earth rotates on its axis. The sun rays do not warm all parts of the earth equally. The heat radiates by the Earth's surface warm layers of air above its direct contact. This is called conduction. Now, the circulation of air, water in ocean causes transfer of heat from one medium to another, from one level to another. This transfer of heat by circulatory movement is called convection. Convection currents in the atmosphere causes sea breeze. During the day, air moves, land becomes warmer and rise. Cool air from ocean moves in to take its place. At night, opposite of this happen. This is because land surface get cooled more quickly than the ocean surface and land breeze are caused. The atmosphere absorbs 34 units of the Earth radiation, but it absorbs only 14 units of the Sun incoming radiation. The atmosphere is heated more terrestrial radiation given out by the Earth than by incoming insolation from the Sun. The atmosphere acts like a blanket. At night, the atmosphere acts like a greenhouse and keep the earth's surface warm by preventing the terrestrial radiation from the escaping into space. During the day, atmosphere absorbs 14% of insolation and thus regulates temperature on the earth. The atmosphere prevents extreme of temperature. The earth would become very hot during the day and very cold at night if atmosphere would be not be there. Some of the factor, the distribution of temperature. Distribution of temperature over the earth is not uniform. The temperature of atmosphere of place depend upon a number of factors like winds, ocean currents, and latitude, distance from the sea, altitude, slope of the land. Here, latitude. Temperature decrease with increase in latitude on either side of the equator due to spherical shape of the earth and annual revolution around the sun. Sun rays strike the earth at varying angles of incidence owing to spherical shape. Oblique or slanting rays not only travels a longer distance but also heat a larger area. Difference in heating of land, conduction, and heating of the sea is known as convection. The sun rays, vertical rays are the hotter than the slanting. Vertical rays, it means sun is on overhead, and slanting rays, it means the sun is not given direct light or heat. The sun rays which fall over the torrid zone travel shorter distance and heat up a smaller surface area, leading to higher temperature. Beyond torrid zone, sun rays travel longer distance. The torrid zone, sun rays travel longer distance. This is because incline of axis and revolution of the earth on its axis. Altitude. The height of place above the mean sea level is known as altitude. Temperature of the atmosphere and altitude are interrelated. The higher of altitude, the lower of temperature. This is because of the following factor. Air is cooler at higher altitudes than on the Earth's surface. The main reason for decrease of temperature with height is that atmosphere is heated from below and more by terrestrial radiation. Air on the surface of the earth is denser and contain more carbon dioxide, water vapor and other gases, and its heat absorption capacity is more in lower layer. The rate of decrease of temperature with height is about 6 degrees centigrade per kilometer above the sea level. This is mean that climbing every 166 meter there is fall of 1 degree centigrade temperature. It is also known as normal lapse rate. Here temperature decrease with increase in height. So you have to be seen about how the warm thick in the layer, but when the high altitude then there is cold thin layer and temperature is decreased now. Distance from the sea. The rays pass through water to a great depth. Water is a mobile and warm water mixes easily with cold water. Because of this reason, water is neither heated nor cooled quickly. However, the sun rays heat in a piece of land more rapidly because unlike water, the heat obtained by the area remains confined to the area and does not mix with other areas of land. The air above the sea is cooler during the time when this is air blow toward the low pressure. Such cool breeze that blow over the earth is known as sea breeze, and this sea breeze cools the coastal region. In the night, the situation is reversed. The sea remains warmer than the land, so the breeze blow from the land to sea is known as land breeze. This makes sea cooler. Now here warm land breeze during the night condition and here cool sea breeze during the day condition. Slope of the land is influence the temperature of place. For example, an area with the steep slope experiences a more rapid change in temperature than a gentle one. That is why mountain ranges with east-west alignment like Alps have a higher temperature on the south-facing sunny slope than the north-facing slater slope. Wind and ocean currents. The land mass get heated or cooled fast. The water mass seems an ocean retain heat for a longer period. Equatorial water remains hot and give rise to the hot currents, while the polar waters are cooled and the winds from ocean and ocean currents transport heat or cold. Coast of the coastal areas, warmer and cold currents make them cooler than usual. We have already learned the warm North Atlantic drift rises and winter temperature of northwest Europe, especially those of British Isles and Norway due to the influence of warm North Atlantic drift. The port of Bergen, about 60° north in Norway, remains open during the winter season, while the ports on the northeast coast of Canada, located in same line latitudes, remain frozen for several months because of influence of cold Labrador currents. Parallel rays from the sun. Here you have to see temperature inversion at very valley bottom on the calm still night.